Hi class, of course, today we continue with exponential equations. This is the fourth class. We want to solve these equations. The first one here is half to the power x minus 3 equal to 8 to the power 2x plus 1. We want to find the value of x, but as you can see, the unknown is found at the top, meaning the power is there, we have the unknown. So that makes it what? An exponential equation. All right, the aim of solving an exponential equation is that we simplify both sides until we are able to have something like a to the x equal to a to the b. So once we have something like this, we have one exponential form here equal to one exponential form, meaning one base with a power equal to another base, one again with a power. Once the bases are the same, we can forget about them and deduce that x is equal to b. This is always our aim. All right, so, but here the base is half, here the base is 8, but we want to make them the same, except if there is no possibility. But 1 over 2 is always equal to 2 raised to the power minus 1. So we can see that this base now generates a power of minus 1. So we can call this the new power. And this one we have at the top is the original power. Why the original power? Because it comes with the question. So now the new power multiplies the original power, which is x minus 3 equal to. So 8 again here, we need a base of 2. Well, 8 itself is the same as 2 to the power 3. So the new power multiplies the original power, which is 2x plus 1. So now we can see we have a to the x equal to a to the b, a format of this. This to this equal to this to this. One base equal to one base. So now we can forget about this. So here we are left with minus 1 multiplied by x minus 3 equal to 3 multiplied by 2x plus 1. If you think the question paper you are dealing with, you have limited space, then you can perform the expansion here instead of rewriting the same thing again. So minus 1 times x is negative x. Negative 1 times negative 1, we have positive 3. Remember, minus times minus is plus. Okay, 3 times 2x is 6x. 3 times 1 is 3. We are solving an equation. Solving an equation means find the value of the unknown. So the unknown is x. So this is minus x. Here is another term in x. We move it here. Minus 6x equal to, here is 3. We move this to the other side, minus 3. Yeah, those with x one side, those without x the other side. So we have minus 7x equal to 3 minus 3 is 0. But we need x, so we divide both sides by minus 7, minus 7. So this takes away this, leaving just x. 0 divided by any value is 0. So this is the result we have for the first exponential equation. Now, if you are interested in copying, pause the video, then you can have it copied. So let's go to the second one. All right, the second one says 4 to the power x plus 1 multiply. Sometimes we have a dot here to represent multiplication. 8 to the power x minus 1 equal to 16 to the power 2x divided by 2 to the power x. As I always say, once you know that we are dealing with exponential equations wherein the unknown is found at the power position, then our target is always to make sure that we have one base with a particular power equal to one base raised to a particular power. This is always what we want to see. One base raised to certain power equal to 1 base raised to. So 1 base, 1 base. That is always what we want. But when you look at the left side, there are two. The right hand side, there are two also. So what do we do? Now 4 and 8, they are not the same. If they had been the same, for example, like a to the power x plus 1 times a to the power x minus 1, would have considered the two bases to be the same. We take 1. Because of multiplication, we add the powers. Mind you, this one means multiplication. You find the dot between numbers or letters, it means multiplication. All right. So what we do is that 4 can give us 2 to the power 2. Just 4 is 2 to the power 2. So 2 is a new power. It has to multiply the original power, which is x plus 1. Multiply by, you can choose to write this way if you think this is the one you are comfortable with. 8 will give us 2 to the power 3. The new power is 3. It multiplies the original power, which is x minus 1. All right. 16 will give us 2 to the power 4. The new power here multiplies the original power. We always aim at having 1 base equal to 1 base. And what we are anticipating is that the bases must be the same. That is always what we want. So here is 2 to the power x. So by the look of things, it is working out for us because base 2, base 2, base 2, base 2. The only thing that is left is we want 1 base equal to 1 base. That is what we need. So this one is 2 to the power 2 by x is 2x. 2 times 1 is 2 multiplied by 2 to the power 3 times x is 3x minus 3 times 1, 3. So here again, 2 to the power 4 times 2x, 8x, divided by 2 to the x. Now these two are the same. Can we cancel them? No, because they are not separated by an equal to sign. So we don't cancel them. So instead, they are the same, we'll take 1. Yeah, because of multiplication, we add the powers. So this power 2x plus 2 is added to this power 3x minus 3 equal to, these bases are the same, we take 1. But because of division, we subtract. So we always write the one at the top first. 8x, this one goes up, minus x. You see, 1 base, 1 base. 1 base, 1 base. So easy. So this takes away this. We are left with 2x plus 2 plus 3x minus 3 equal to 8x minus x. You can choose to simplify here before writing the same thing again. 2x plus 3x, 5x plus 2. 2x plus 3x, 5x plus 2 minus 3 is minus 1. 8x minus x is 7x. Now we collect like terms. This is 5x equal to, this is 5x. We move this to this side to become minus 7x. So what goes to the right hand side? The one without x, which is 1 instead of minus 1. So 5x minus 7x minus 2x equal to 1. We need x. We divide both sides by minus 2. This goes with this, this goes with this. Positive divided by negative is negative, and 1 over 2. So this is what we have for the 4th class. Thank you for watching. Do not forget to follow, like, share, and comment. See you in my next video.